The gap between these two thick plastic plates is formed by this gasket. When fluid is forced to flow through the cell, all particles in the same neighborhood are subjected to the same pressure gradient. The fluid velocity varies, being zero at each plate and a maximum midway between them. But at all points on a line perpendicular to the plates, they are moving in the same direction. In the Healy-Shaw apparatus, colored fluid is injected into the stream through a number of regularly spaced holes, and since the streamlines originating in any neighborhood remain close to one another, the lines of color remain sharp. When they are deflected by a thin disc placed between the sheets, they assume the same form as those of an ideal fluid when deflected by a cylinder of the same cross-section. Now, instead of a solid body, a source is started in the flow. Here is the flow round a half body. The red dye shows the internal streamlines. When the rate of fluid flowing from the source is constant, the streamlines are sharp. But when the flow from the source changes, the lines of color become blurred because the faster particles, midway between the top and bottom plate, no longer find themselves close to the lines of slower particles which started earlier from the same neighborhood. The experiments you've seen are limited to fluids which possess the simplest possible relationship between stress and rate of strain. Since most fluids do in fact conform very closely to this ideal, these experiments are a very general application.